Okay, so we're going to look at another method of finding volume of a solid, and this is called the disk method. So in that same note packet that we had from the previous video, you're going to open up lesson 6, and this is really not too bad. Basically, the concept here is that whatever shape we have, so let me see if I can get here. Actually, I'm just going to go ahead and start the first example, and I'll explain it to you as I do that. So I'm looking at example number 2. Okay, and we've got a line. This is a linear equation, so let's go ahead and graph this linear equation. Okay, it's got a y-intercept of 1, and it's got a slope of negative 1, right? So this is going to be just a linear equation like that, okay? It says set up and evaluate each integral that gives the volume of the solid by revolving the region about the x-axis. So this is what we call solids of revolution, right? Right, solids of revolution. So what happens is we have a function, revolution, okay? We have a function and we revolve that function around the axis. So if I were to revolve this around the x-axis, okay, I would get, okay, oh no, try and do that again here. So I'd get that side of it, right? And it's revolving, so it forms this shape that looks like this, okay? Now, we want to find the volume of that three-dimensional shape. So what we're going to do, we're going to use the disk method, and just imagine if I could slice this shape with infinitely many disks, okay? Each one of these disks is actually a cylinder. It's a cylinder whose height is the thickness of the disk, or in this case, whose height is the change in the x value, right? So we have infinitely many disks that we're slicing out of this, and we're finding the volume of each one of these disks or cylinders. So that's what we're doing with the disk method. Now, the volume of a cylinder is pi r squared h. Well, in our case, the h is the change in x. So we're looking at pi r squared delta x, or dx, right? So the only thing we have to figure out here now is, I can't do that, is the actual value for the radius. So if we look at this, the radius is going to be, the radius of each cylinder is going to be found by using the y value of the function. Okay, so the radius here is negative x plus 1. That's my radius, okay? So our volume, we're still going to use the volume is the area of the function times dx. So when we're using the disk method, the volume is going to be pi r squared dx. And of course, we have to figure out what that r is, okay? So in this case, my volume will be, I'm going to bring the pi out in front. The r is negative x plus 1 squared dx. And now, what are my upper and lower bounds? Well, we're going from 0 to 1, because I'm just having infinitely many disks that are being sliced out of this, right? All these disks are being sliced out of it from 0 to 1. So that's my integration. And when I'm going to go ahead and expand this, so this becomes pi times the integral of 0 to 1 of x squared minus 2x plus 1. And when we integrate that, we get pi times x cubed over 3 minus 2x squared over 2 plus x evaluated from 0 to 1, which comes out to be 1/3 pi. Okay, so when we're trying to find the volume of the solid that's formed by revolving the function around an axis, we're going to use the disk method. Okay, we're going to use the disk method, and really what we're doing is we're using cylinders. Okay, so we're using cylinders, and we're using infinitely many cylinders, and for each cylinder, the height of the cylinder is your dx. So then we have to figure out the radius, and the radius in this case is just the y value. Okay, so let's look at another example. Okay, so here we have y equals the square root of x. So let's just graph that, right? Y equals the square root of x. That's going to be just a curve that looks like this, right? X equals 0, so x equals 0 is the y-axis, and x equals 4. Okay, so the region that we're talking about is right here. Now we're going to revolve this around the x-axis. So imagine taking this region and spinning it around the x-axis. If we do that, we're going to get kind of like this bowl-looking container. Okay, that's the solid that we're looking at, and we're trying to find the volume of that solid. Okay, so what we're going to do, again, we're going to take infinitely many slices that will end up being cylinders, right? Or discs, right? So they're so thin that instead of calling them a cylinder, we just call them a disc, right? So we're going to have infinitely many of these, and we're going to sum them all up. That's what the integral does, right? It sums them all up to get the volume of this particular shape. So remember, your volume is the integral of your area dx, right? So in this case, my volume will be pi r squared h, right? The volume of a cylinder, okay, just to remind you again, right? Here's your cylinder. The volume of the cylinder is pi r squared h. Right? In this case, the h is the thickness of the disk, which is your dx. Okay? So what's the upper and lower boundaries of my integral? Well, I'm going from 0 to 4, right? Because it's being bound by the line x equals 4. Pi. Now what's r? Well, r is the height of the curve, or the height of the graph, which means r is whatever the y value is. So r in this case is the square root of x, r squared dx. Okay, so that means we're looking at, I'm going to bring the pi out, 0 to 4, square root of x squared dx. So the volume is equal to pi, integral from 0 to 4 of x dx. Okay, and when we integrate that, we're going to get 8 pi. Now, while you're watching this video, it would probably be a good idea to go ahead and do this integration. I just don't want to take extra time during the video to do it. So you should, at this point, be pretty comfortable with integrating x dx. Okay, I will integrate anything that's any more complicated than that. Okay. Okay, let's look at the next one. Right, this one is very similar, except that note that it says it's revolving about the y-axis. Okay, so that's going to make it different. So we've got y equals x squared, right? So that's a parabola, right? It is revolving about the y-axis. So this one, the wording on this one's a little bit weird. All right, because it's revolving about the y-axis, and it says from 0 to 4. So that actually means that I'm revolving about the x-axis, the y-axis, from 0 to 4. So I'm talking about 4 on the y-axis. So I know that I'm going to be integrating from 0 to 4. Okay. Now, if I'm revolving about the y-axis, then that means that I need to change my equation. Okay, instead of y equals x squared, I need to change it to x equals. So it has to be a dy with respect to y. So I don't want to use x squared because it has to be with respect to y. So I need to rewrite this. So if y equals x squared, then it means x equals the square root of y. Okay, and remember, I'm looking at pi r squared dx, and the r, okay, the r is, right, let's take our discs here so we can visualize it. Okay, here's my disc. So the r is this radius right here, right? That's parallel to the x-axis, so it's the x value. So the r is actually the square root of y. It's the x value. Okay, so we're looking at pi r squared. So it's pi square root of y squared. Okay, so again, we'll take the pi out of there. Square root of y squared dy. Okay, and this ends up being the same thing as above, except this time it's in terms of y. 0 to 4 y dy, which equals 8 pi. Okay. Okay, let's look at example 5. So we've got e to the x, right? Well, e to the x, let's see, when x equals 0, we've got 1, right? And this is an exponential function, so e to the x is going to go something like this, okay? Revolving about the x-axis from 0 to 2. Right, 0 to 2, it's going to revolve about the x-axis. So we've got something like that, okay? And we get this funny looking shape like this. Remember, it's revolving, so it's forming this circular shape, okay? So if I look at my disc, right, there's my radius. Okay, kind of looks like a ham bone, doesn't it? Okay, you can tell Easter's on my mind. Okay, pi r squared. This time it's going to be with respect to x, so it'll be dx. The r is parallel with the y-axis, so the r is the y value. So that'll be pi e to the x squared dx, okay? All right, so our volume, I'll bring the pi out, right? We're going from 0 to 2. And this is e to the x squared dx. So here we've got to do a little bit of work. So we're going to go 0 to 2. This is going to be, e to the x squared is e to the 2x. Remember when we multiply exponents, when the exponent's outside the parentheses like that, we're multiplying them. Okay. Now I need to integrate this. So, right, I know that the integral of e to the u is equal to e to the u. So let's work with that. Let's let u equal 2x, which means du equals 2 dx, okay? All right, that means I need a 2 here. And if I put a 2 there, I have to put a 1/2 in front. Okay, so we're looking at 1/2 pi. Now I'm going to leave the upper and lower bounds off because it's not going to matter later, right? We're going to go back and switch it. So this will be e to the u, right? Here's my u right there. du, right? There's my du. Okay. Now the integral of e to the u is e to the u. So let's substitute it back in now. So that will be e to the, remember u is 2x, so it's e to the 2x, and we're integrating that from 0 to 2. Okay. Okay, so this will be 1/2 pi, and that's going to be substituting the 2 in there, e to the 4th, minus substituting 0 in there, e to the 0, which means we have 1/2 pi e to the 4th minus 1. And we can leave our answer like that because we're not working with a calculator here. Okay. Now, if this was a free response question on your exam, you're going to have to put upper and lower bounds here. So remember what we talked about the other day, right? The lower bound in terms of x is 0. Well, if I substitute a 0 in here, in terms of u, the lower bound is still 0. The upper bound is 2 in terms of x. So if I put a 2 in here, it's going to be 4 in terms of u. So we're going to put those upper and lower bounds there, and then we have to make sure we put them there if it is a free response question. Okay. Now, if it's a free response question, okay, you could solve it right here and not worry about substituting back in, right? So this would give us 1/2 pi, right? Substitute the 4 in there, e to the 4th, minus, substitute the 0, e to the 0, which is 1. So we get the same answer, okay? You can do it either way, depending on how complicated it is, okay? But remember, free response questions, right, you've got to make sure that you are accurate with your calculus. So you'd have to go ahead and put those upper and lower bounds in there when you write your integral in terms of u. Okay, so we're going to jump over to the homework section. So we're going to look at homework 8.6. Find the volume of the region bounded by the given functions and revolved about the given axis. Okay, so we've got the function x squared minus 4x. Okay, so let's see, x squared minus 4x. All right, so this is going to be a parabola that's actually going to go down like this, all right? Something like that. It's bound by that function and the line y equals 0. Well, y equals 0 is the x-axis. So this is the region that we're referring to. And we are revolving it about the x-axis. So it's going to come up here. Okay, so we're going to get kind of an egg. Okay. All right, so our cylinders, right, because it's revolving about the x-axis, right, our cylinders are always going to be perpendicular to the axis of revolution. Okay, that's really important because in this one, it almost feels more natural to make our cylinders the other way. Okay, right, our disc or our cylinder will always be perpendicular to the axis of revolution. That's really important. Okay, so because in this particular case, it looks like it should be the other way. Okay. Okay, so again, here's my radius, and my radius is going to be, right, it's going to be an x, right? It's going to be what the y value is, right? Sorry. It's going to be what the y value is. It's perpendicular, it's parallel to the y-axis, so it's going to be the y value. So our value, we are integrating from, okay? I don't know my upper and lower bounds, so in order to figure that out, right, this is in terms of x, right? It's going to be pi r squared dx, right? So in order to figure that out, I need to figure out where it's crossing the x-axis, okay? So writing it in stages like this can be helpful, just kind of helpful to wrap my brain around what's going on. Okay, so I'll come back and do those in a minute. This is pi. So what's r in this case? R is the y value, so r is x squared minus 4x. Okay, so it's going to be x squared minus 4x squared dx. Okay, so again, right, my disk is always going to be perpendicular to the axis of revolution. And because of that, I know that my radius is the y value. So I set that all up. So now I have to figure out where it crosses the x-axis. So we're going to look at x squared minus 4x. Where it crosses the x-axis is called my zeros. So we set that equal to 0. So I am going to factor out an x. So it's going to cross the x-axis at 0 and at 4. So there's my upper and lower boundaries. Okay. Okay. So now I'm going to go ahead and expand this. So the volume equals pi. We're going to integrate from 0 to 4. And that's going to be x to the 4th minus 8x to the 3rd. Plus 16x squared. So I expand that out. Okay. And let's go ahead and integrate this. So that will be x to the 5th over 5 minus 8x to the 4th over 4 plus 16x to the 3rd over 3. And we're evaluating that from 0 to 4. Okay, now I'm going to go ahead and change this 8x to the 4th. I'm going to change that to 2x to the 4th. I'm sorry, 8x to the 4th over 4. So that's 2x to the 4th. Okay. All right, so that's going to be pi. And it's going to be, let's see, 4 to the 4th, so 1024 over 4. I'm sorry, over 5 rather. 4 to the 5th, 1024, yes. Minus 2 times 4 to the 4th, which is 256. Plus 16 times 4 to the 3rd, that's actually 1024 over 3, right? That's the upper bounds, and then when I substitute the lower bound in, everything's going to be 0. Okay, so this comes out to 512 over 15 pi. Okay, all right, the next one. We have the line y equals x, all right, so that's this, let me draw that this way here. Right, so that's this line here. The line y equals 3. Okay, 1, 2, 3. And the line x equals 0. Okay, so x equals 0, that's our y-axis. Okay. Okay, so this is the region that we are talking about right here. Right, it's bound by the line y equals x, y equals 3, and x equals 0. We are rotating that around the y-axis. Okay. All right. We're rotating that around the y-axis. So here is my, it's like a cone, right? So my disk is always perpendicular to the axis of rotation. So my disk is going to be right here. All right, so this disk is going to be in terms of y, so it's going to be dy. Okay. So my r, what's r? R is the x value, right? Y equals x or x equals y. So r is y. So this is going to be pi times the integral of y squared dy. And we're integrating with respect to the y-axis, so it's going from 0 to 3. Okay, so this value will be pi. This will be y to the third over 3 from 0 to 3, which equals 27 over 3 pi, or 9 pi. Okay, let's look at number 3. So we have y equals the square root of 9 minus x squared. So we should recognize this as a circle, right? Y squared equals 9 minus x squared. That means x squared plus y squared equals 9. So we should recognize this as a circle with a radius of 3, but we're only talking about the positive value of that circle, right? So the radius of 3 so this is the circle, okay? But now this says that I'm bound by the line y equals 0 and x equals 0, which means the y-axis and the x-axis, right? Since this is just a positive square root of 9, let me do it this way. The circle, I'm only talking about the positive half of the circle, okay? Bound by the line y equals 0 and x equals 0. So that means I'm talking about this region right here. Okay. And we are revolving that around the x-axis. And we're revolving this around the x-axis. So we're going to get this bowl shape again. Okay. All right, we're revolving it around the x-axis, which means my disk is going to be perpendicular to the axis of revolution, which means we're talking in terms of y, right? So the volume equals the integral of pi r squared. I'm sorry, in terms of x. I said y, didn't I? In terms of x, sorry about that. Okay. Okay, so my radius, what is my radius? My radius will be the y value. So my radius is the square root of 9 minus x squared. So we're looking at pi times the integral of the square root of 9 minus x squared, don't forget, radius squared, dx. Okay, and then what is the upper and lower boundaries? So we're looking at the x-axis, right, because it's the axis of revolution. So we're going from 0, and then it crosses again at 3. So it's from 0 to 3. So my volume equals pi times the integral from 0 to 3 of 9 minus x squared dx, which ends up equaling 18 pi. Okay. All right, two more. See here. So here we're talking about y equals x cubed, right? X cubed looks like this, right? The line x equals -2, so that will be right here. And y equals 0. Okay, so this one's much more clear, right? I'm talking about this little region right here. Okay. So get the rest of this off of here. Okay, so now we're going to revolve that around the x-axis. So it's going to go like this, right? All right, and so here's my disk. So this is going to be, the volume is going to be in terms of x, so it's dx, right? Axis of revolution, pi r squared, right? And we're going from what coordinates? We're going from 0 to -2, right? Because it crosses the x-axis at 0, right? Since it's bound by the line y equals 0, it's bound by the x-axis. We have to know where it's crossing the x-axis, and I know that this crosses the x-axis at 0. So we're going to go from 0 to -2, but remember the lowest number goes on the bottom, so it's -2 to 0. Okay. All right, and then r is going to be the y value, so that's x cubed squared dx. So we're looking at the volume being pi times the integral -2 to 0 of x to the 6th dx. And that comes out to 128/7 pi. Okay. Okay. The last one of this type. Yeah. Y equals the square root of x. So that's this line here. Y equals 3. So that's up here. And it's rotating about the y-axis. So we're looking at this. Okay. And here's my shape here. Okay, so that means that my disk is going to be perpendicular to the y-axis. Okay, so volume equals the integral of pi r squared dy. Okay, so r is, right, it needs to be, r is going to be the x value. So let's work with this equation. Y equals the square root of x. So if I square both sides, then that means x equals y squared. So r is y squared. So we have our volume equals pi times the integral of y squared squared dy. What's the upper and lower bounds? It's a y-axis, so 0 to 3. Okay, and this comes out to 243/5 pi. Oops. just 243 over pi. Not sure where I was going with that. Okay? Okay, so we're going to stop there on this video. And I will go over the other type in the next video. Next, we're going to talk about the washer method. Okay.